In case of positive integer, there is no decimal place, then characteristic will be 1 less than the number of digits of that positive integer. For finding the antilog of this number, 2 is used, or 2 determines the position of the decimal point. Therefore, we first see the row headed by 0.37. First we go to the row headed by 0.37 in the antilog table. Then 2 is there, we follow that column. After that 0.37 column headed by 2, then from the mean difference we get the value of 4. Good morning viewers, good morning students who follow my classes. Welcome to btosacademy. I am going to conclude actually the logarithm topic, logarithm. Already I have discussed so many sums, etc. But the main thing is how or where we apply logarithm. Actually, in case of complicated calculation involving multiplication, division and power or index case, we use logarithm. Then to find the value of that expression, we use anti-logarithm. I take an example like this. The given expression is of this form: e to the power x into b to the power y divided by c to the power z. Already I have mentioned the complicated calculations which are of this form: a to the power x into b to the power y divided by c to the power z. We apply here logarithm, then anti-logarithm to calculate the value. For that, we first take this expression as, let capital N is equal to this. Then taking logarithm, log n, already I have mentioned base will be 10, is equal to log of this expression applying the laws of logarithm. It will be log a to the power x plus log of b to the power y minus log of c to the power z. I have not mentioned here base. Already it is discussed that in case of algebra, base will be 10. Therefore, as per formula, this will be x log a plus y log b minus z log c. Now, using log table, we calculate the value of this expression. Say it will be p. Then n will be equal to antilog of log n to the base 10, that is antilog p. Now antilog p also calculated from the log table, antilog table. Now I discuss how to find the log of different numbers finding logarithm of different numbers. This is serial 2. Case 1. I would like to discuss like this. First case, if the given number be positive integer, given number is positive integer. Already it is mentioned that the logarithm of negative number is not possible. Given number is positive integer. Example, I take example. Log of 235 to the base 10. Log of 235 to the base 10. One thing to be mentioned first, logarithm of any number, logarithm of a number consists of characteristic and mentation. Logarithm of any number consists of two parts. The first one is called characteristic and the second one is called mentation. Now, how to determine characteristic? Actually, we first note how many digits are there before the decimal starts. In case of positive integer, there is no decimal place, then characteristic will be 1 less than the number of digits of that positive integer, or in case of other numbers, 1 less than the integral part of the given number. If there be no digit before decimal, then characteristic will be 0 if the digit after the decimal point is non-zero. Now, if the number starts with decimal point and the digit after the decimal point be non-zero, then the characteristic will be 1 bar. Actually -1, but in case of logarithm we say 1 bar and write also 1 bar. Now I take this example. Log of 235. First of all, I note that there are 3 digits and no decimal point. Therefore, the characteristic will be 1 less than the number of digits. That means 3 minus 1, 2. Now, after that we put decimal point. Now, for the mantissa part, we follow the log table, and log table is there in every mathematics book. Generally at the end pages we find log tables as well as anti-log tables for finding the logarithm of 235. And one thing, log table starts with 10, then 11, then 12, so on up to 99. Then to find the log of 235, we follow the row headed by 23. Headed by 23. Then for 5, the number having 5 at the top, actually the column headed with 5 and along the row headed by 23, and from that log table, can we show the log table? No. In the book, students, learners, you follow the log table. You see at the top there is logarithm, written logarithm. Now you see the column. First column starts with 10, 11, 12, dot dot dot, and up to 99. Then from this log table, the row headed by 23, then the number below 5, column having 5, we write that it is 3711. First I follow the row headed by 23, then follow the column, headed 5, headed by 23, then after that digit 5 is there, therefore I follow this column 5, then 23 5 means 3711. Follow that 3711. Therefore characteristic is 2 and mantissa is from the log table 3711. Therefore we have found the logarithm of 235 to the base 10. Now to get 235, we have to take, already I have discussed that theory, we have to take the antilog of this one. Therefore antilog to 0.3711. For getting the antilog, we have to follow the antilog table. You see this is antilog table. At the top it is written antilogarithm, and antilog table starts with rows headed with 0.00, then 0.01, then 0.02, then 0.03, then 0.04, etc. up to 0.99. At the end there is 0.99. Now for finding the antilog of this, first of all we go to the row headed by 0.37 in the book. 0.37 in the book. 0.37 in the anti-logarithm table. Then there is digit 1. For that we take this column. Then there is also another one. For that we have to move to mean difference, and for 1 we see there is another one. That means antilog of 2.3711 will be 2350 plus 1. That means 2351. 2351. One thing you note, for finding the antilog of this number, 2 is used, or 2 determines the position of the decimal point. Therefore, we first see the row headed by 0.37. 2 is not affecting here. Therefore, antilog of this one is 2351. Now we have to place the decimal point. Since the characteristic is 2, therefore before the decimal point there is 2 plus 1 digits. That means there are 3 digits before the decimal point. Hence the antilog will be 235 point decimal point 1. Now we took the number 235, but after taking antilog we get 235.1. Actually we don't get the actual value. There will be a bit difference. Thus we have got logarithm of 235 as well as antilog of the logarithm of 235, and finally we get 235.1. Now I increase another digit. That means example log 2351 2357 2357. I increased one digit, 2357. For getting the logarithm, first we see there are 4 digits. This is positive integer. Now 4 digits are there, therefore characteristic will be 3. Now for finding the logarithm of this number, we move to the log table and see the row headed by 23. Already we have seen 23 and 5. For 5 the number is 3711. 3711. I write here 2, 3, then 5. The column started with 5. We have 3, 7, 1, 1. Then there is another 7. For that digit 7, we move to the mean difference column. You will find there is mean differences column at the right side of the log table, and for 23 we follow the row headed by 23, and For that we find the mean difference is, for 7 mean difference is 13. 2, 3, 5, 7. 2, 3, 5, 7. Mean difference 3, 7, 1, 1. From the mean difference table, we find at the row headed by 23 and mean difference table 7, there is 13. This 13 is to be added with this 3711, so that we get 3724. Therefore, it will be character antisa part will be 3724. 3724. First of all, we go to the row headed by 23. Then on the right side there are digits. For 5 we get 3711, and for 7, that is at the last place, we go to the mean difference column, and from that we get 13. 13 is to be added with this 3711 to get the logarithm of this whole number. Therefore, finally, logarithm of 2357, that is 2357, is equal to 3.3724. Note that characteristic determines the position of the decimal point. Thus, we have calculated the log of this one. Then, for getting the value, original value, we have to take the antilog of this number, and already I have discussed how to get the antilog of this. For that, first we note this 0.3724 antilog. First we go to the row headed by 0.37 in the antilog table. Then 2 is there, we follow that column. After that 0.37 column headed by 2, then from the mean difference we get the value of 4, that is added to that 0.372, that is from antilog table. Point 0.37, then 2, then 4. 0.37 we write from the antilog table. 0.37, 0.37, then 2, it is 2355, 2355, and then from 4, mean difference 4, 0.23, sorry, 1706. Sorry, I have wrongly copied. 0.37, sorry, 0.37, 2355, 2355, and from mean difference column 4 we have 2. That means we have to add here at the end, so that it will be From antilog table, we have found the antilog of this one. Now, antilog of 3.3724. First, I write this value 2357. Now, 3 determines the position of the decimal point. That means there will be 3 plus 1, that is 4 digits before the decimal point. Therefore, the number will be 2357. We have got the original number 2357. We took the log of 2357. Finally, after taking, antilog is also 2357.